The last part of the notes we talked about ionic bonds, and ionic bonds is where you've got electrons transferred from one to another. And again, these only occur between metals and nonmetals, okay? Covalent bonds, what happens is, let's say you got carbon, and carbon has 4. So does it give up 4? Does it take in 4? It doesn't do either. What it does instead is it situates atoms around it and they share electrons. So they have to stick together. So now you're forming molecules. When we did ionic bonds, we formed ions. You had positive and negatively charged particles. With covalent bonds, they share electrons and they stick together. So molecules are formed by covalent bonds. Ions are formed by ionic bonds, okay? So here's an example, hydrogen. Hydrogen only has 1 electron. It will not give up its 1 electron. It's like having an only child. So instead, if you take 2 hydrogen together and put them together, they will share those 2. They each will share their 1 electron, and now they have 2. Remember, everybody wants 8 except for hydrogen. Hydrogen only needs 2. So now, by sharing each one of them contributing 1 electron, they have 2, and so then they're good. And so hydrogen forms a molecule, and the 2 of them stick together. And this is how you would draw it. You'd have the 2 hydrogen, and then they're sharing each. There's an electron from each they're sharing, okay? All right, so the formation of the hydrogen is because they overlap their orbitals. And remember, an orbital is a place where you find 2 electrons. Well, there's 2 electrons. So each atom contributes 1, and then that's how they end up with 2. Now, all the other stuff needs to have 8 around it, okay? So the metals have to give up their electrons, and the nonmetals take them in. But if you put 2 nonmetals together, now what they're going to do is they're going to share their electrons, okay? For example, chlorine, okay? Chlorine has 7, but now it's not reacting with a metal. It's reacting with another chlorine. So what's going to happen, like the hydrogen, they're going to come together, and you're going to end up with this chlorine and this chlorine. They're going to share 1 electron from each. So when you draw it out, these are the chlorine that are the atoms that are already, electrons, that are already around here, and these are theirs. Then 1 comes from this chlorine and 1 comes from that chlorine. So by sharing 1 from each, now they both have 8. And you just look around, see, 2, 4, 6, 8, 2, 4, 6, 8. So what they're looking for is 8, okay? And the ones in the middle, they're sharing, okay? And by doing that, now it becomes a stable molecule. They have to stick together, okay? It isn't one takes them and one gives them. They stick together and share those electrons, and that's called a covalent bond, okay? And here's your diatomic elements. We talked about them before: hydrogen, fluorine, bromine, and iodine. They stick together, okay? So by sharing electrons, they end up with their 8, okay? And again, that's why we have a lot of diatomic elements, okay? You can replace, sometimes you'll see a line, and this represents 2 electrons. I'm just going to use dots because I don't want to confuse you anymore. But if you see a line represents 2 dots, okay? If so instead of drawing it like this, you draw it like this, and that would represent the 2 dots. Here you got them around, but they're sharing 2. It doesn't matter, it's not a big deal. If you don't want to do dashes, if you want to do dashes, just remember 1 dash is 2 dots, okay? All right, sometimes in order to get enough electrons, they have to share more than 2. Like oxygen. Oxygen's O2. Okay, oxygen has 6, and it needs 2 more. But each of them need 2 more. So the only way they can get enough electrons to be stable is to share 4 electrons, 2 from each. And if you count them, there'd be 2, 4, 6, 8. And this one, 2, 4, 6, 8. So by sharing 4 electrons, because these 2 dashes would represent 4, that's how oxygen. So sometimes you have to form a double bond. Okay, nitrogen actually forms a triple bond. So there's 2 from this nitrogen, and then it puts its other 3 in the middle, and then this one puts its 3 in the middle, and then 2 here. So they share 6. So if you go 6, 7, 8, 6, 7, 8. So sometimes you have to form double bonds and triple bonds in order to get the amount that you need. And these bonds, again, remember a dash represents 2 lines. Triple is the most. You can't have a quadruple bond. I don't know why, but you can form single bonds, 2 electrons, double bonds, 4 electrons, or triple bonds, 6 electrons. And that whatever they need to get stable, that's how they do it. Okay, so ionic and covalent bonds represent the two extremes. You know, you're either transferring your electrons or you're sharing electrons. Okay, here's a one thing about covalent bonds. Okay, when you have an ionic bond, they just transfer the electrons over. That's it. Covalent bonds, they're sharing them, but sometimes they're not sharing them equally. Okay, here's hydrogen. Hydrogen only has one electron. It will share its one electron with chlorine. So there's two electrons right here that they're sharing, one from chlorine and one from hydrogen. The thing is, hydrogen is a smaller molecule, or a smaller ion, I mean. Atom's the word I'm looking for. Sorry, you guys. Than chlorine is. So what'll happen is the electrons will get pulled closer to the chlorine than the hydrogen. And you'll end up with poles. You end up with this end being positive and this end being negative. So even though the overall charge is 0, you end up with positive and negative ends because of unequal sharing. And that's polar covalent. And honestly, most compounds are polar covalent. Okay, if you have covalent compounds. In order to be truly covalent, non-polar they call it, it's almost like when you share between the same two electrons. Okay, so polar covalent means they're sharing electrons, but they're not sharing them equally. So when we talk about covalent, they're sharing electrons, but there's two kinds. Sharing them equally, that's non-polar, and sharing them unequally, that's polar. Okay, if you're talking about two hydrogen, of course, that's going to be purely covalent. That's going to be non-polar because they're the same size. They're going to share the electrons equally. But in this one, they don't share them equally because chlorine is bigger, so it pulls it closer. So you have a negative end here and a positive end here. Overall, the charge is 0, but you end up with poles, and that's why they call it polar, kind of like a magnet. Okay, and then here's ionic, the other end of the scale. So when you're looking at bonds, you have purely ionic where they transfer their electrons. You have polar covalent where they're sharing electrons but not equally. And then you have, they say purely, we always call it non-polar. Okay, and that means they're sharing the electrons equally. This is the gamut that it can run when you're talking about bonds. Okay, all right, so there's extremes when you're talking in the bonds, but again, it's easy to figure out which one is formed. Okay, the easiest way to figure out which bond is formed, again, is two nonmetals is going to be covalent. A metal and a nonmetal is going to be ionic. But there's also something called electronegativity. Every element has a measure of it. And what it is it's a measure that says how much do they want an atom? How much are they attracted to those electrons? Okay, so in here, what you can do is you can look up the numbers, and there's a periodic table with all these numbers on it, and you just subtract the difference between them. Okay, so like here, this is the one I was talking about with hydrogen chloride. You got a negative end and a positive end. Well, instead of having to figure that out, you can actually subtract two numbers and come up with exactly if it is or not. Okay, chlorine is more electronegative than hydrogen. So again, they share electrons but not equally. That's why you end up with, they're more over here, that's negative, less over here, that's positive. Okay, how do you figure that out? Okay, the scale of electronegativities is developed. It was developed by Linus Pauling. He's a chemist that did a lot of work. He was the Pauli exclusion principle. Okay, but anyway, he assigned a value to all the elements according to how much they want electrons. The highest is fluorine, and its number is 4. That's the highest number. The lowest number is 0. Okay, so fluorine's number is 4, which means it really, really wants electrons. And if you think about it, fluorine has 7. It really wants that one bad, okay? The higher the electronegativity, the stronger it wants a bond, okay? So now, if you want to figure them out, all you have to do is subtract the two elements that you're making a bond between, and the difference will tell you what type of bond you have, okay? And again, there's a chart. I don't know if there's one in your book. I will have one for you to download to look things up, okay? Okay, but the bond polarity is determined by the difference between the electronegativities. Okay, here's a chart. And I think, yeah, I'm pretty sure this is in your book. But again, I'll get another one for you. Okay, so let's say I'm going to do a bond between magnesium and chlorine. Okay, magnesium is 1.2 and chlorine is 3. When I subtract the difference between those, I get what, 1.8? All right. The scale, let me see if they have it here. I don't think, oh yeah, here's the scale. I'll give you a different scale because the one in your book is different than most other books. I don't know why you'd think they'd get it together, but if the difference, when you subtract the difference between the two, if it's from 0 to 0.3, that is a nonpolar covalent bond, okay? 0 to 0.3 is nonpolar, okay? If the difference is 0.3 to 1.7, that is a polar covalent bond. And if the difference is higher than 1.7, then it's an ionic bond. So all you have to do is use the differences in their electronegativity to figure out what type of bond it is. Okay? Bond polarity is determined by the difference in the electronegativity. Okay? And here they have it greater than 2. It's actually 1.7, you guys. So if the difference is 1.7 or higher, then it's an ionic bond. Okay? If it's less than 1.7, it's going to be a covalent bond. They're going to share electrons. And again, if it's from 0.3 to 1.7, that's the scan, okay? If it's in that range, then it's a polar covalent bond. They are sharing their electrons, but they're not sharing them equally, okay? If it's 0 to 0.3, then that is a non-polar covalent bond. In other words, they're sharing the electrons totally equally. You'll find them right in the middle, okay? Okay, so bond polarity is determined between the differences. Oops, sorry about that. Okay, and again, I'll give you a chart like that, and we'll go through it more. Okay, so nonpolar covalent bonds are very small, and there's no difference between them, especially if it's the same electron. If you take hydrogen and hydrogen, obviously it's going to be 0. So if you have two identical ones, they are definitely going to be nonpolar because they're going to share them equally because they both have the same electronegativity. You don't have to look them up and subtract them, you guys. Okay. All right, here's between carbon and sulfur. Okay. Carbon is 2.5, sulfur is 2.5. The difference is 0, so this is a nonpolar bond. Okay, they share their electrons equally. Hydrogen and chlorine, those two together, you know, both 2 hydrogen or 2 chlorine, not hydrogen chlorine, but just 2 hydrogen, 2 chlorine. These are nonpolar because they're going to be right in the middle because they both have the same electronegativity. If you subtract hydrogen and chlorine, you'll find the difference is higher, so that will be a polar covalent bond. Okay, and here's sodium and chlorine. Oh, sodium is 3. I think chlorine is like 0.7 or something like that. So you're going to get a difference of 2.3, something along those lines. That is definitely ionic. Okay, they are not together. They're ions, and the ions are attracted to each other. But these guys actually stick together. Okay. All right, so when you're talking about looking at it, polar covalent bonds, you have 2 atoms that are sharing electrons, but they're not sharing them equally. So here's between like phosphorus and oxygen. Okay, always start with a higher number. Okay, phosphorus is 3.5, oxygen's 2.1, I think. I don't know. I'd have to look them up. But anyway, start with a higher number, 1.4. No, I think oxygen's a higher number. Yeah. Anyway, the difference is 1.4. That is a polar covalent bond. When you draw it out, you always point toward the more negative one. So yeah, this would 3.5 is oxygen, phosphorus is 2.1. But subtract the difference is 1.4, so you know it's a polar covalent bond. Okay? And again, here we have a difference of, with nitrogen and carbon, the difference is 0.5. Okay, that is also a polar covalent bond. Okay, they're not sharing the electrons equally. So you got a kind of a scan here. Okay, so polar covalent bond would form between which one of these ions? Well, I know it's not these two because that's ionic, and that's ionic. Well, fluorine and fluorine is going to be nonpolar because they're the same. So it's got to be hydrogen and chlorine. I didn't even have to look them up. Okay, and here's all the differences using the chart. And again, I'll get a chart for you. But beryllium and fluorine is 2.5. That is ionic. This is nonpolar. This is polar covalent. This is ionic, and this is nonpolar. I'm trying to think how many more we have here. I only have a few seconds left here. Okay, that's perfect. This is where we're going to end. Okay, so we're going to look at how to figure out if a bond is ionic, covalent, and if it's covalent, if it's polar or nonpolar. Okay, alrighty, that's the notes for today.